Assalamu alaikum students. Today we are moving to the final lecture of state of matter, and that is about diffusion. As you can see in this picture, that these are few molecules of gas. If you spray perfume at one corner of the room, just suppose that these are the molecules of perfume that you have sprayed at one corner of the room. What happened? This will start spreading. How would you come to know that they have spread out? If you go another corner of the room, you will find its fragrance even in the whole room. It means that these molecules have spread out. They are moving from a higher concentration where you have sprayed these molecules. There is higher concentration of these. So the movement of the gaseous molecule from a region of higher concentration to the region of lower concentration means where there are no molecules of that perfume. That is called lower concentration, means no concentration of the molecules of perfume. So they are spreading out from higher concentration to lower concentration. That is called diffusion. This is called diffusion. So what is diffusion? The spreading of substance through medium like air or liquid. These molecules are spreading in air. There is air all around it, so the gaseous molecules are being spread into the air. This is called diffusion. So the rate of diffusion depends upon the molar mass of the substance or density. Here, students, you need to understand that what is the difference between diffusion and effusion. Diffusion is the spreading of the molecules. There is, you can say that there is no hole from where they have to move through. If the molecules have to move through a hole, for example, if there is some hole over here, so these molecules will move through this hole. This is called effusion. And spreading of molecules from higher concentration to lower concentration, that is called diffusion. And the diffusion depends upon molar mass of the density. Let's talk about Graham's law of diffusion. What Graham said about diffusion. He actually observed the diffusion of gas. He said that the rate of diffusion depends upon molar mass, or we can say that it is inversely proportional to the square root of molar mass of density. It means that lighter gases can diffuse faster. You can see here there are two gases which are coming out from water. This is an experiment of separating hydrogen and oxygen from water. You can see that hydrogen bubbles moving faster. ये देखिए इसका जो bubble है यहाँ पे bubble ये ज़्यादा बड़ा है because diffusion of hydrogen gas is much faster as compared to oxygen gas. Why? Because hydrogen is lighter than oxygen, so it will diffuse faster than oxygen. Let's see what happened in the case of liquids. You can see here how diffusion takes place in water. You can see here there are few crystals at the bottom of this beaker. Dark soluble crystal at the bottom of water. If you will leave it untouched, you will see that its molecule starts spreading in the beaker. And after some time, this third stage will come in which the whole crystal will equally spread out into water. So it means that water molecules or liquid molecules can also move, but their movement is much slower as compared to the movement of gas. Again, the reason is the same. What is the reason? Liquid molecules have much attraction between them as compared to gaseous molecule. Gaseous molecule can spread much faster because they have higher kinetic energy as compared to liquid molecules. Here you can see again another example of diffusion of liquid. I've taken few drops of ink into the water. You can see that the in the first stage diffusion was slower. Then second stage is going to be faster, and in the third stage, but slower but faster than the gases. So it was the diffusion and the diffusion of gases and liquids. Let's talk about Brownian movement. Who was Brownian? Who was Robert Brown? Robert Brown was actually not a chemist, he was a botanist. In 1827, he observed the property of the movement of pollen grains in water by microscope. Pollen grain is the yellow dusty powder from the male part of the flower. He found out under the microscope the abrupt, the random movement of pollen grains. He said that the continuous rapid, this is the zigzag motion. Look, you can see that zigzag, random motion of the molecule. First going here, then here, here, abrupt motion, random motion. So he said that the suspended particles in any of the liquid, suspended particles means which do not dissolve in the liquid. So the suspended particle could be any heterogeneous mixture. That can be fats particle in milk. That could be sulfur particles because sulfur is also not soluble in water. Sulfur particles in water. So any insoluble particle in the liquid will show this abrupt movement, random movement, that is called Brownian movement. Let's try to understand it with experiment. This is sulfur crystal. Mix some sulfur crystals into the water. You know that it will make a heterogeneous mixture. After stirring, its particles will remain into water. And if you examine a drop of that mixture under a microscope, you will see that the abrupt or random movement of these sulfur particles into water. So, zigzag motion of the particle, of suspended particle, was confirmed. According to Brownian movement, the suspended particles means heterogeneous mixture in which the particles are visible, small particles are visible and not soluble in water. Their zigzag motion can be observed. So this was the Brownian movement and the state of matter, the whole chapter that we had studied. Okay, students, I hope there will be no problem in the lecture of diffusion and the Brownian movement. So this was our last lecture. Okay, Allah.